Hello and welcome to TIS-100. And holy crap, I don't know what all these things are or what to do with them. Instruction count, statistics, node count, cycle count, create a new program, open the save directory, segment map, specification editor. Oh my god, there's so many things here. I literally have a manual open right here on my other monitor. You can't see it, unfortunately, but hello, we're still in shock from Uncle Randy's sudden passing while we wait on word from the examiner about the cause. We are coping as best we can. I've been occupying myself sorting through his things, especially his computers. Of course, I took one look in the garage, and it all looks like a bunch of junk to me. I'll send some pictures when I get a chance. For now, this is the machine that was set up on his workbench when he died. Maybe you'll be able to figure out what he was doing with it. He would have liked to know someone was going to finish his work. The tessellated intelligence system is a massively parallel computer architecture comprised of non-uniformly interconnected heterogeneous nodes. It's ideal for applications requiring complex data stream processing such as automated financial trading, bulk data collection, and civilian behavioral analysis. Yeah, it's some sort of crazy thing that I have to learn how to use and stuff and do things with it. And I'm just glancing at the document and just kind of, there is a lot of stuff here that I don't know anything about. And hey, now we're on to instruction sets. Right, but what I'm going to do here is I'm just going to click self-test diagnostic. Okay, that doesn't do anything. I click the segment map. That's not doing anything. Specification editor. Okay, so that's the segment map, and this is the specification editor. I can create specifications. This is what? Oh, this is if I want to create a, okay, yeah, that's for creating your own custom puzzles. Okay, so I guess create new program means, ooh, interesting. All right, read a value from in X and write the value to out X, read a value from in A and write the value to out A. So, move up, down. Oh my god, what the hell is going on here? I don't understand. Oh, here's in X, here's in A, here's out X and out A. Okay, so this one's already set up. Move whatever comes in from the up to the down. Move from up to down, and then go out at the bottom. This side, however, has nothing. So I'm guessing what I need to do is I need to move up to left, and then here I need to move right to down, and here I need to move up to down. Here I need to move up to right, and then finally here, move left to down. Let's go ahead and run this. And okay, it's running test 1, test 2, test 3. Okay, so we've gotten around the corrupted nodes, and I'm on the top of the leaderboards. Of course, so is everyone else, because it's the most simple puzzle. So it's kind of a it's one that you can just. There's no other solution. There's just oh there is another solution potentially. Compute node diagnostic, microcode dump. Can't find a pen right now, so I'm just going to take notes here. Looks like short-term storage. Got this one at the swap meet today. Fellow wanted 454, but I talked to down 200. Good deal. No idea who makes this thing. Never heard of the TIS series, and the architecture doesn't look like anything I've seen before. Ask the guys down at the blah blah blah, but no joy. Randy has a mystery on his hands. Okay, so this is a note from him, so that doesn't actually help us in this case. All right, I'm just gonna run it fast so I can go back to the segment list. So the self-diagnostic test says that things are working now. Now we can do signal amplifier. Oh, so there's multiple slots that you can save for different things. That's interesting. All right. So read a value from in A, double it, and write it to out A. So we have in A up top, down, up, that. So in here, well, I need to know how to multiply. And I don't even know if we have a multiply label in here, an instruction for multiplying. And it looks like we don't. Okay, so we have a command called add, which is add the value of source is added to accumulator and the result is stored in accumulator. So we have an accumulator. So I think we need to first move up to accumulator, then we need to add accumulator, then move accumulator to down, and then here I'm going to say move up to right, then I'm going to say move left down, move up, down. So we move our inputs into the accumulator, we add the accumulator to itself, then we move that to down, and then move it along the chain. And it looks like it is running as expected. Okay, so we just have a little bit of code in one of them, and the rest of them are just kind of very, very simple. Interesting. Okay. Yes. Let's. Okay. I was about to start speeding it up because I was thinking that's something that could be done better. That's interesting, though, that apparently there's a faster way to do it. So if there's a faster way to do it, what would that be? Oh, no, the difference was in, what was it? The difference, hold on. The difference was in cycle counts, and maybe moving is slower than adding. So maybe if I just do add to accumulator twice, because the accumulator starts at 0. Uh-oh. Oh yeah, the first one needs to not be, yeah, okay, stop it. I know it's wrong. That was kind of dumb. I need to add up to the accumulator. Okay, so now, oh, really? Oh, because the accumulator doesn't reset. So if I put it down here, move 0 to accumulator, that works, and that is even slower. How is there a faster way to do this? I'm really curious about that now. Okay, well, that'll be something to figure out later, I suppose. Add accumulator and then move the accumulator down. Up to the accumulator, add accumulator, blah, blah, blah. That's the one that works, and I will consider that done. So, various things. It's a programming game. It's a puzzle game. It's on the Humble bundles as a sale right now. There's a Humble Staff Picks bundle. It's only got 15 hours left at the time of recording, so I'm sorry about not getting this done sooner, but I really wanted to show it off before it was too late to get it in the current bundle, but it's going to be pretty close to too late. Read values from NA and NB, write NA minus NB to out P, and write NB minus NA to out A. So what I will do, well, let's see, just here should move up to down. Here we'll just move up to down. And I'm curious what it's going to say here. Interesting, it looks like there's some kind of static memory in this thing, encoded something or other. Okay, move up and down, up and down. Okay, so here, what do we want to do? There needs to be some communication, some communication between the two. I'm really not sure at this point. I'm just going to say move up right, and move as a copy, right? It's not actually gonna move it. Source is read and the resulting value is sent there. I'm not sure if I'll be able to do 2 moves at once like this, but I'm gonna try it just to start with. Move up to left, move up to accumulator, which I'm guessing they're gonna conflict with each other. So that one has moved in. Okay, wait. Oh, it doesn't say anything about what's in there. Okay. So at this point, we have 0 in the accumulator, 0 in the accumulator. Okay, so these are definitely, they're trying to communicate to each other. So they are communicating with each other. But what's happening is, stop it completely. Step 1. Okay, there's an input coming in, 44 and 93. That input is passed down. So they both move it to each other. Oh, and at that point, there's a new input going in. And they're going to try to move nothing into the accumulator. And then they're actually never going to end up moving anything into the accumulator. That's weird. How do I do this? I have no idea how to do this. This is crazy. All right, so well, I'm going to go ahead and try to figure this out. And if I do, I will let you know. They block each other. I read the documentation. I think I figured it out. Yay! Or at least I figured out a way that works. And I was kind of worried about how it would work, if it would work. Let's just pause this for a moment so we can talk about what it's doing. So the first 2 and the bottom 2 are just doing exactly what I was doing before, moving the up to the down. But the difference here is, remember, these things are happening in parallel, and the thing that I had to watch out for was that if you tell something to communicate with the other side, it waits until the other side does something with that piece of information before it can continue. So at the same time that this one, the left one, is moving to the right, and I just realized you can't see my cursor. That's weird. I thought I enabled that. Yeah, so I accidentally had it so you couldn't see my cursor this entire time. I am sorry about that. Anyhow, so they both move what they get into their accumulator. This one moves its to the right, which means it's in this little communication bit. On this side, it saves it into this backup storage, whatever. And then at the same time, well, actually, at the same time, this one is waiting because it can't do anything until this does something with it. This one subtracts the left value from the accumulator, which is the value that it needs to pass on down. We swap the value, which means it swaps between the accumulator and the backup, meaning we save the result that we need to pass down, and we bring back our original. We move our original to the left so that it can then be subbed right. So sub right waits until it receives something. So you can see right now I'm sending a 96, and that's the instruction we're on right now. We're sending a 96. It's waiting to subtract that from what it has, which is 81, which you'll see somewhere over here. We have 81 and 96 are inputs, negative 15 and 15 is our outputs. So this one will soon go into a negative 15 as soon as this instruction is done. Then it'll move from the accumulator down and it's done. On this side, it's a little more complicated because it then has to swap again and then it can move it down. There's probably a better way to do this, but this is the way that I did. That works. And so here we go. Yay, faster. And let's see, I am 354 cycles, and someone's done it in 203. I've done it in 6 nodes, whereas they've also done it in 5 nodes. Fewer cycles and fewer nodes, and instruction counts, fewer instructions, and yeah. So I am not the best at code, but it was fun nonetheless. And yeah, so if you're interested in this, if you want to, oh, you can title your programs. How do I title you? Can I title you? How do I title you? How do I title you? How do I... Okay, yep, let's go back. How do I title you? How do I title you? How do I title you? I need to find out how to title this, because I really want to be able to title program... whatever, I don't care. But in any case, yes, fun things to do and stuff. Thanks for watching, and as always, go program your calculator.